Hello and welcome back to L3.3, lesson 3.3, or maybe it looks like this, lesson 3. Okay, here's a diagram to examine. Describe the sequence of steps you think were used to construct this diagram, beginning with the first figure and ending with the second figure. Okay, so we got this, we end up here. First thing I notice is, what's the difference? Well, these two lines are here. How'd they get there? Well, they connect to point C. How did point C get there? Well, it doesn't look like there's any information about why C is there. So this was arbitrarily picked. Arbitrarily picked, which just kind of means randomly or like no reason. Or you could, any point, you could have picked, this could be C, this could be the C. Doesn't matter where you pick C, but you do connect it to A and B. How about this line L? Can it just be randomly, arbitrarily picked? No, because this and this mark mean that the midpoint is here. Midpoint. So this line has to go through the midpoint, and this line is perpendicular. Now maybe they made a perpendicular bisector construction, but whatever they did, they put that line through the midpoint of that segment, which means that segment had to be there before. So step 1, make segment AB. Yeah, so the segment has to exist before you can find the midpoint. Put line L perpendicular to AB through its, how about its midpoint? Well, through the midpoint of AB. Or, well, that's everything here. Now we're over here. Select. You just choose point C. But point C at least has to be on line L. On line L. You don't need those. I just select point C on line L. Make AC and BC. We're done. We're out. Learning focus. Organize and sequence proof statements using two-column format. Examine a claim about points on a perpendicular bisector of a line segment. Tia and Tahani are doing their math homework together. One of the problems is to prove the following statement. Prove that the points on the perpendicular bisector of a segment are equidistant from the endpoints of the segment. Endpoints are A and B. All points on the perpendicular bisector are equidistant. So it doesn't matter if you're point C or C, 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 or C, or it doesn't matter where you are, you will be the same from A and the same from B, same distance. If you're in this packet, prove the points on the perpendicular bisector segment are equidistant from the endpoints of the segment. Tia and Tahani think this diagram will be helpful to prove this statement, but they know they will need to say more than just describing how to create the diagram. Tia starts by describing the things they know, and Tahani tries to keep a written record by jotting notes down on a piece of paper. So here's Tia's statements, here's Tahani's notes. In the table, record in symbolic notation what Tahani may have written to keep track of Tia's statements. In the examples given, note how Tahani is introducing symbols for lines and points in the diagram so she can reference them again without using a lot of words. If you're in this packet, that was right here. Now we're over here. Draw AB, okay, locate its midpoint M and draw a perpendicular line L through the midpoint. Hey, we said that. We need to start with the segment as perpendicular bisector already drawn. Okay, they're doing it, they're drawing it. We need to show that any point on that perpendicular bisector is equidistant from the two endpoints. So I can pick any arbitrary point on the perpendicular bisector, let's call it C. And that point C represents all points. We're analyzing any given point. So we need to show that this point is the same distance from the two endpoints. So we need to prove that AC is congruent to BC, or actually better yet, because we're saying equidistant, and distance is a measurement, not a thing. Distance is a number that describes a space. Numbers are equal. So AC without a hat, this represents the number. You may remember from a couple lessons ago. This actually represents a number in geometry. It represents the measurement of the distance of segment AC. We want that to equal BC. I just screwed that up. Here it is. AC equals BC. I put it in the wrong box. So that's what we're trying to prove. Same distance from the two endpoints. The segment AC has the same measurement as segment BC. If we knew the two triangles were congruent, we could say that the point on the perpendicular bisector is the same distance from each endpoint. Yeah, if the two triangles on the left and right were congruent. Oops, those are supposed to be endpoints. If they're congruent, then this matches that, and those are corresponding sides. Then those would be the same. That's AC and BC. So we need to